Köszönöm szépen, és
So, Ada, you take the floor. Thank you very much.
hát egyrészt nagyon megkönnyítette Félix
First
a
of all,
dolgomat,
Felix made it very easy for me because he mentioned a number of things that I will just make reference to during my my talk. And also, I'm very happy to see that there are so many of us in the room, because it seems that although there has been no social debate or professional discussions, coordination going on as concerns the investment in Paks, and therefore about the most important parts of Hungarian energy policy, while there would be a need for that. So I think that this is also an important message, or can be an important message to the decision makers. So we were considering this for a long time when looking at the literature, the background literature for presentations. It always says that you should start with a joke. And I was thinking long and hard about a joke, like 3 photovoltaic panels walk down the desert in 2030. Which of them is Hungarian? None of them. That's the punchline. But that's not so funny, let's admit. So if you look at the PA association, the head of the PA association sitting in the audience, is probably not really funny. And I also wanted to start my presentation with the good news. I want to announce that in 2030, Hungary would be very well off for the electricity system without Paks 2 as well. So let's start from the end. Practically speaking, we created a model which by 2030 could describe the entire Hungarian electricity system, and we can say that even without the enlargement of the nuclear power plant, the electricity system, or the power system, is able, or would be able, to take care, to cover all the needs, which is clear from these calculations. So this model is in comparison to the original electricity or power strategy. It calculates with a very high rate of renewables, almost 1/2 of that, and in terms of output, nearly 1/3 of the output, so that would be close to the current rates of Germany. We also know by now something that I already made reference to in the beginning of my speech, that unfortunately there was no debate. Therefore, we are also not aware of any of the studies or research laying the grounds for this investment. We are not aware of we don't know the costs. We don't even know what type of reactor the government wants to build in addition to the current reactors or units. And also there was no discussion with the experts. So experts of nuclear physics were also not requested to participate in the preparation of this decision. We also think that there's no need to take an urgent decision, which has been pointed out by the experts several times. We could have a lot of time to decide, because in fact the first step should be, or could be, that we decide what social and economic structures can be forecast, predicted for 2030, for which we should build power plants, and what kind of power plants, because we believe that there is an alternative there is a scenario in which we do not necessarily need yet another huge investment. And as it was already explained by Felix in his talk, this is a long process, and they also had an outlook until 2050, and by 2050 it would be possible to construct a new energy system, energy structure, which is based on principles that could be a decentralized or a long decentralized model. Now, what is the difference between a decentralized model and the centralized energy system? Now, centralized systems are usually based on traditional fuels. Following the industrialization in the 1950s, it's built on large power plants, and it means that a few large power plants need to be operated and coordinated by coordinators. Now, in a resource-poor country like Hungary, this means high level of energy dependency. We know that Hungary is one of the most dependent countries within the European Union from external power sources, including gas and also nuclear fuel rods, while a decentralized system is basically built on self-sustenance. It will be based on local fuels and sources. Those will be prioritized, and everything else comes only second. Therefore, the decentralized system is much more flexible than the centralized one, because if we think about fleet of small ships or a huge tanker or carrier, which is very difficult to maneuver, that means that a system composed of small elements can be changed, transformed very easily, while the transformation of a large of a system composed of larger elements is very cost-intensive, because if we decide once that this is not what we need, then it will be very costly to depart from that model. Therefore, a decentralized system is also much more stable if it is well developed, if it is well constructed, well put together, and the right government policies are aligned, while a centralized system is much more vulnerable, where the stoppage of a larger power plant can create major problems. Now, as it was already mentioned by Felix, the ownership structure is also quite different. In the centralized systems, these are large enterprises which govern, and enterprises own large power plants, while in a decentralized system, these are local farmers. The users, the consumers of energy themselves become producers of energy, or generators of energy, which means that their autonomy and energy democracy increases. This is a strange concept that probably has already been recognized by the government itself, and it's not probably by accident that tax that has been levied on solar panels is a sign of that recognition. We also know that in case of large investments, the risk of corruption is much bigger, which in case of the Paks project is something that we also describe in one of our studies. So it offers possibilities for corruption at the magnitude of the subway line number 4 that was built point. So when we talk about autonomy and energy generation, when it comes so close to us, as it does in a decentralized system, their waste is also on a much lower level. Efficiency increases. Smart systems become necessary, which means that the efficiency of resources is on an elevated level. And last but not least, employment is an important issue. In terms of energy, this is a problem that comes on the surface on a regular basis. In a decentralized system, it is not jobs that are generated at single points, or at certain points, but it's rather throughout the country. Repair of PA panels, maintenance works. This is something that will become necessary everywhere in the country. So these are the characteristics of decentralized versus centralized systems. But let's see how this looks like in practice. This is a very schematic chart about both systems. In a traditional centralized system, there's a number of large power plants on high voltage. They will distribute power over a number of transformation investments and applications, and thereby transfer electrons to households and businesses, while in case of a decentralized system, it is based on a large number of smaller generation sites, and they can use the energy themselves as well, which means that grid loss and the self-consumption of these systems is on a lower level. This means that energy efficiency itself becomes part of the system. So in the centralized system, it's fossil fuel, traditional fuels which get priority, and renewable sources are only secondary, while in case of decentralized system, as you could see in the energy boom in Germany, renewables become more and more important, and they will lead the process, and then other sources will just leverage the existing capacities. Our targets are for 2030, but we also know that 2050 is the ideal target or time horizon by when we can expect such a system to develop. If society forces that to happen, and if the profession is also backing up this model, if we can use good enough arguments to make it happen. Why 2030? Why did we choose 2030? It has a number of logical reasons. One is the Hungarian energy strategy, which looks ahead until 2030. The current and effective energy strategy also looks at 2030. This is by when the target figures of the European Union are devised. For renewables, it's 27%, we know, and for total energy consumption and for energy efficiency, another target of 27% and 40% reduction in terms of climate related objectives. According to the council meeting held in last November. So by 2030, the next units in Paks should also be constructed and operational, but the old ones would also be would also operate with all 4 blocks, which means that 2030 is a rather good time horizon, because we have 15 years ahead, which is a plannable or foreseeable time period. So there are possibilities for planning and for considering the right government measures or policies. And last but not least, I have been listening to the story about stopping power plants for 20 years now, and maybe they will actually be phased down. Many of them have already been phased down, but they should be replaced by then to an extent where a replacement is actually necessary.
What have we taken into account when making our calculations? First of all, we have chosen a method that seemed to be well established. I do hope I will be able to convince you about that. First of all, we outlined energy future vision. According to our opinion, that is quite rational, realistic. We have collected a number of data, have carried out analyses, studied the prices, energy efficiency potentials. We have been working with documents in order to create a realistic future energy vision. We have studied statistics, trends, expectations concerning the energy sector, which have been built into this model. We have defined certain target numbers and loaded it in a software which we did like very much. Why? We decided to select the energy plan. This is a Danish developed software, which is specifically interesting for us because this is a software taking into consideration renewable energies at a system level. We are aware of the fact that by 2050 Denmark plans to cover all energy resources against renewable energies. This is why they developed this software, which has a breakdown hour by hour, which means that it's capable to handle all the changes that are necessary in an energy system. At the same time, it also includes or covers the whole energy system, both consumption from specific consumers' point of view, and also energy carriers are also taken into account, including combined energy heat or fuel that is required for the transportation system. So this is a model covering full energy system, but in my presentation probably you will hear much more about the electricity energy aspect of the model, because we are talking about Paks number 2. This is what we are going to study. I simply, with this software, would like to show you how that is possible to be used for the Hungarian energy sector. Additional characteristics of this software is that it takes into account climate or weather conditions as well. So we have uploaded characteristics of the Hungarian weather conditions. So this is very important from a heat energy point of view. This is a software largely been used recently, and this is why it seems that it is really reliable software. Since it is globally used, probably it will also be possible to be used in Hungary as well. But in order to be convinced about that, we have had to carry out a validation process, as a result of which we collected a number of data concerning one specific year, and then we checked if the results would be the same what is issued or published by the Hungarian Energy Office and by the Hungarian Central Statistical Office. So we collected data on efficiency, the hourly usage of specific energy resources, weather conditions, from the given year. All those data have been uploaded to this software, and finally we got a result which showed that official statistical data and the results of this model fall very much in line. There are just minor differences. So actually it means that the software can be used for all energy resources. Data so were very similar to what can be read in the Central Statistical data accumulated with regards to 2011. The software is usable, so now we can use the software in order to analyze, based on our future vision, how the system is going to look like in the future. Let us see what our future vision we have created. I will focus mainly on renewable energy sources, because that will be the basis for a future distributive or decentralized energy system. We could have been much more. We could have had a much more radical approach. We could have taken into account much more renewable energy resources. But then it was decided that our estimates will be much more conventional, because this is how it is possible to convince the whole industry that by 2030, based on a relatively conventional approach, the system will be able to cope with the given environment. The history of the Hungarian energy forecasts predictions is a history of failures. For the past 20 years, the consumption prognosis have been much higher than what we have come to in reality. We should also know that the Hungarian energy strategy relies on a 1.5% energy increase annually, and that is a prediction for the future 15 years. This is a relatively very high increase. The Hungarian grid company, the Mavir, already now has decided to withdraw from that high percentage of increase, and instead of 1.5, they decided that roughly about 0.8 would be much closer to reality. According to my personal individual opinion, that will even be less than that. So this is the curve that we think to be realistic for the forthcoming 15 years. At the same time, with regards to heat supply, we're less optimistic, or we were more optimistic, saying that the heat consumption will fall in Hungary by about 1/4 of what we have today. That was based on certain potential analyses done by ourselves, at least partly. Here we see the gas consumption that will decrease, but wood heating will also fall before 2030. I think that is a very important part of the Hungarian energy policy. This is actually the cheapest energy source what we have in Hungary. We're about energy production. We think that in majority of cases consumption will drop, so an increase can only be expected in the field of service provision. I don't think that is surprising. There are enormous potentials in the industry, and that would be very important to be taken into account by governmental measures. The same is true for agriculture. An improvement of efficiency is expected in the field of agriculture as well, and that should also be supported by governmental plans or regulation. The energy strategy takes into account a huge electricity consumption and also that is also true in the field of transportation vehicles. According to our own opinion, we think that by 2030, 1/5 of vehicles used in Hungary will be replaced by so-called green or modern vehicles, cars. We'll see how intensively the current set of cars will be replaced. It is expected that BMW 3 will probably be replaced by a green Toyota or some other green cars. That seems to be realistic, so this is what was taken into account by us using a relatively conventional approach.
Ahogy eddig is hallhattuk, a rendszerirányítás, a villamosenergia tekintetében kulcsfontosságú. Hogyha a rendszerirányítás nem tud adaptálódni,
that if the energy system is unable to
energetikai
be adjusted according to the new energy model, then problems will occur. According to our experiences, all the problems have been tackled in one or another way in the past, so the same is expected for the future. This is a very simple slide. It shows a different approach of a centralized decentralized system. Here we have the so-called base load power investment, which in our case would be the Paks investment. Then we have the carbon-based power plants, and then we have relatively minor opportunities for renewable energy producers.
As opposed to the other model, which was, I mean, the previous one was top-down, but in fact, it's the system steering is so sun and wind is preferred in I mean renewables, and then the leveraging peak load needs can be satisfied on longer term, of course on longer term from renewables, but it can be covered. And one more interesting feature that I would like to point out as regards this particular chart, it is possible, which are in during the day, in the morning and in the evening hours, these are manageable. I think that the so-called demand time management method is there, or even through a tariff system or other measures, something that makes it possible to extend these peaks and load them, reload them to time slots when there's a lower demand, and there's a huge literature of that, and an international literature. So the difference between the two systems is, I think, quite obvious from these two particular charts. I think that in order to go from this system to that system, it's not just infrastructure investment that's needed, but also a complete paradigm change from decision makers, policy makers, and system managers alike. So this is actually where we would like to shift the Hungarian energy system to, and also the regional energy systems, because a single prophet will not be able to change this and such a change, such a major change, cannot be done over this short period of time. But there's good news, and the good news is that the European Union has opted for this particular system. So by 2050, according to the various road plans, this is practically where the European Union wants to go. So you should have no doubt that if Hungary stays here in this system, then it will be a weird little island on which we live in terms of energy policy and the energy industry, which will most probably on longer term make energy much more expensive, and also social costs on that basis. Let's look at the results. Well, I could have started by this already, because usually it's just a couple of figures that we get from all of the studies and research. Let's look at the official script, how Hungary should look like in 2030 in terms of power capacity, and how should it look like in our view. You can see that's why there are these huge circles here. The other structure, these these circles are smaller and much more leveraged, much more balanced. We know that these 4,400 megawatts would be in a single point of the country, while the 2,800 megawatts of wind power and 1,400 megawatts of photovoltaic energy would be spread all over the country in all different points, thereby also generating jobs and possibilities for the people to earn a living by work. And these almost 3,000 megawatts of heat and electricity generation capacity would be spread, rather spread over the country, which also includes about 1/3 of biomass-based heat and electricity generation. So that would be a very good foundation for leveraging power if wind turbines are not working or if PA panels are not generating power during the night. And we could also go further into these figures, but I think that the very point of my talk today is to demonstrate this very different approach that such an energy policy and the establishment of such a system, of such a new system, requires from Hungary. Now, to talk about renewables, because that's probably something that I should speak about separately. According to statistics from 2011, 6.4% was the share of renewables in power generation. According to the official scenario, should be 15% in 2030, which I think is a rather modest amount in comparison to the potentials of Hungary versus Germany, for example. If you just think about the sun or the number of sunny hours, it's quite obvious. Now, in our scenario, the share of renewables is 27%. From the total generation capacity, which is also a nice figure because it's close to the European target figure of renewables. And also in our model, in 2030, the export need of the country would be just 1.5%, which is a fraction of what is being imported into Hungary right now in terms of electric power. And last but not least, I think that of course we can debate about why we thought that this would be the rate of distribution of renewables. There could be more sun or more wind. We can also talk about whether or not geothermal sources and power generation on the basis of geothermal could be in a situation in by 2030 that you can use it more for power generation, and that's also actually our objective, that there should be a professional debate, a discussion about this, so that we can also integrate aspects into this model which refine it, which make it even better, which made the whole system even better. That would lead to a much more precise vision, a much more precise model, and thereby we could also say more precisely what the economic characteristics of the new system would be, how much will it cost and who will pay. Because we know who will pay the Paks investment. It's us, just to give this quick response, either in terms of taxes or energy prices, power tariffs. But is it perhaps not better if it's small investors coming rather than public money used to construct new power plants, but rather let the market operate? It would be very important to learn more whether the carbon emission of such a system is lower or higher. And it's also an important aspect how it can look like in 2040, how the power system can look like in 2040 without Paks 2. And when all 4 current reactors have to be phased out by 2040, is it possible still to operate the system? And this is something that we will look at this year. And I hope that we can rely on your attention then, and I can still say that we don't need nuclear power in Hungary. And this is actually also an invitation to you that we should talk about this together rather than just ourselves in our ivory tower building these models. Thank you very much.